Entering in the top seven for which was Sierra Hansen, Lily Cross, Lauren Warder, Riley Holland, June Price, Lee Lauderdale, and Danny Ward. The team runs this Saturday against Worcester in the season. Great job, ladies. Good luck this week.
And I want to hand you guys notes for today.
Auditions for the fall play around the world in each state will take place Wednesday and Thursday after school in the fall. If you're interested in auditioning, the sign-up sheet for the time slot is on the team's outdoors. The fall play is open to students 9th grade and above, and no prior theater experience is necessary. Our first paintball outing will be Saturday, September 18th. The sign-up sheet and informational flyers are in the middle school guidance. To participate, you must sign up and guided, have a signed waiver form, and a permission slip. If you have any questions, please see Mr. Director. Attention all students interested in wrestling this year and not in the fall sports. We will begin our preseason workouts on Tuesday, September 7th after school. Open match will be from 2:45 to 3:45, and lifting will be from 4 o'clock to 5:15 on Tuesdays and Thursdays. Lifting will only be on Mondays and Wednesdays from 4 to 5:15. See Coach Mattingly, Coach Berger, or Coach Nikki if you have any questions. Have a great day, LHS.
Oh, okay.
Tomorrow's review, thank you so much fun. And then Friday, research it too. So, we'll keep you this tomorrow and bring your back practice. Take the test on Friday, feel prepared, you can wait over the weekend, but there's no easy situation there. So,
I know, it's like not out of my hands for Friday. I'm gonna try and use it, honestly, just if I was.
I'm sure you can. I mean, you don't want to. But we're gonna that just keep checking things. Okay. Good. Casey, hey, say hi. Is that how long? Okay, any questions? Okay. Make sure your finances are in interval notation. Maybe no. Yeah, that would just be interval from negative.
The orange
is. Alright, and what I would encourage you to do is double check those answers in the back. Make sure they're right.
Wait, this is free.
Okay.
No, it's not. This is on. You have to add, wait, 15% into 40%.
Actually, it's been a while.
Yeah.
Alright, I got all your homework.
So I was thinking it is something minus X there.
Okay.
So. I think it's minus X. It's like a random number somewhere. It's like there's always two X's. I don't know if there's two X's. It just confuses me so much. Well, it has to be something with X. Because if you have two X's, then try to get the other, like, if you're subtraction, right? I'm so good at this game. I'm so good at this game. Forgot.
Double check here.
Give your mom a try.
You have to, that doesn't mean what. I represent that one way. You have that number.
X plus
You got two
4
branches going.
something minus
Get
X.
two things going the same way, you can write that with one equals. With one single interval.
100
So double stack those. Okay.
equals
Oh, they go back.
130,
He knows that.
100.
Any questions?
And I'm like, I've never been so good at this before. Josh, that's not right.
I don't know.
If I don't know what 4 times 100 is.
Get the answer. No. Wait. Alright, make sure your answers are in interval notation.
Okay, because all those would have
Instructions didn't tell us to put on the golden tape.
No, I think I told you to. I said,
Yeah.
I said all those answers. And if you look and if you check your answers in the back, let's see what they look like.
About 10.
Let's see. 1, 6 is this.
The embarrassing.
Oh, it says write the solution set and interval notation.
Yeah, I did those ones.
That one just said like solve.
And when you get to 50.
Oh, yeah. All right. Yeah, negative infinity to 5. 65. 63, they got no solution. 53. Negative infinity to 11 halves. 51, negative infinity to negative 2. And 2 infinity. All right. All right, we'll get to this one here in a second. All right, with kind of obviously some spiking in COVID, I'm gonna be a little on the cautious side, and I'm gonna, when I'm interacting with you, I'm gonna be wearing a mask. So at least that's the plan. Probably when I'm up here teaching, I'll take it down when I know I'm not gonna come out to you for that. So just obviously. It's spiking a little bit. We're dealing with some quarantines and more than that. So I'm going to be a little bit cautious for that. We will take a test Thursday. Look at your homework again. Let me encourage you, check your answers in the back. Multiple people I see have incorrect answers or incorrect form of the answers. You got to take the time just to look back there and just see if you are on the right track or if you're writing it in the right notation. Okay, make sure you do that. All right, what'd you get for this one? Okay, Amanda Yoakley, did you get an answer? Oh, we're missing Brian too. Hold on. Sorry. Amanda, did you get an answer?
I got 40 grams of the 50% gold alloy.
That'll be correct. If you have 40 grams, that is correct. All right, for that. So let's set that up. Make sure you go there. You will have 3-word problems on the test. You'll have a mixture problem like this. You'll have a distance, rate, and time problem, and then you'll have like an interest problem. Okay, I'll tell you that now. Okay, so ahead and finish. All right, how much of a 15% gold alloy? It's always percent times amount, so we don't know the amount. So it's 0.15 times X. Must be added to a 40% alloy to attain 100 grams. That is 30% pure gold. So we know the final amount. Okay, and let me do that. The final amount is 30 grams, so it's 0.3 times 100. Well, if we got X and we know the final amount's 100, what do we do? One of them's X, what's the other amount? 100 minus X. Okay, this is very consistent with some of the earlier ones. So you got to set it up like that. When two things have to add up to 100, one of them's X, one of them's 100 minus X. Now, it doesn't matter where the X goes or the 100 minus X. Your work will just look a little different. So 0.15x plus, what is that, 40 minus 0.4x equals 30. And then it looks like it's negative 0.25x. If I subtract 40 equals negative 10, and I'm hoping that gives me 40 grams. But that should be our answer. Okay. And we'll hit some of this a little bit more, but like I said, there will be 3 different type of word problems on the test. There is a lot going on in this chapter. Homework-wise, any questions on the homework? Okay, anything I can go over? Oh, I got thumbs up. That's pretty good. Anybody else? All right, here's what I want you to do. On the notes I gave you today, it says solve the following inequalities. Write your answer in interval notation. They're all either have 2 or negative 4. You didn't get notes. Andrew, did I give you guys notes? No. I didn't do it. Okay, those first 6. And there's a number line underneath if you want to use that to help you, but list it in the simplest form. Okay, in those first six. So x is greater than 2 and x is less than or equal to -4. What's your answer? If you're not quite sure, move on. Okay, so see what you come up with for those 6. That's basically all the situations that you can come across. Also, let's start submitting online just because, just get in that habit. If you have any issues, let me know. I'm not going to go through the procedure right now. If you don't submit online, it's not going to be docked at this point. I'm not going to dock you. But if you can, I will have it set up where you can submit online. And that would be your homework. Ashley, here. All right, let's start looking at what you got here. X is greater than 2 and x is less than or equal to -4. Okay, no solution. No solution for that one. Because it's an and problem. Greater than 2. So here's 2. You'd have an open dot to the right. Here's -4. I'd have a solid dot. I'd shade it to the left. Okay, since it says the word and, it has to satisfy both conditions. Okay, it doesn't hit anywhere both conditions. That's where it would be overlapped. Don't overlap, no solution. Okay, now what happens if we change that to or? Okay, we change the word to or, less than or equal to -4. You got the same graph. Okay, we got the same graph. They don't overlap, but since it says the word or, all it has to do is satisfy one equation or the other. So you have to have both sets of answers. When we have this case, when it's an or, you have to write it in the proper format. That would be -infinity to -4 with a bracket there, union, can't put a comma, you got to put a union, 2 to infinity. Okay, so that would be the case there where you have 2 distinct sets that are both part of the answer. So changing the word from and to or changes the whole thing. Okay, now we got them going like kind of the same way with the word and or with the word or. Okay, so for 3 and 4, 3 should be infinity to negative 4, and then 4 should be negative infinity 2. Okay, so and is where they overlap, or is where you take actually the bigger of the intervals. So for 3, if I start at 2, open dot going this way, and then negative 4. Okay, I want to know where they overlap. Okay, and then for or, you're going to take all the answers. So that'd be a little bit easier. All right, 5 and 6. Okay, so for 5, okay, they're going opposite directions. Since it's the word and, it's got to be where they overlap. So less than 2, and then bigger than negative 4, bigger than or equal to negative 4. The only spots where they satisfy both of them, okay, will be in between those two. And you have to write it in that format, negative 4 to 2. Okay. And then the last one, since it's the word or, okay, and then you got 2 graphs that are passing through each other, it's going to be every number, negative infinity to infinity. So those are all the different cases you can come up with and or in dealing with inequality. Okay, so you got to make sure you know those, and hopefully those all make sense to you. Okay. So that kind of finishes up section 1.6, which was part of 1.6, but we obviously is a little bit more involved with some of the problems, but you got to make sure you know how to graph them and write a final answer. So you cannot give me a final answer and say, oh yeah, x is less than 2 or x is greater than or equal to negative 4. I got to see that interval notation for all of that. All right, dealing with 1.7, equations and inequalities involving absolute value. Okay, we're going to solve equations first, and we'll deal with inequalities. I think you're going to be pretty familiar with the equations. Inequalities you've had before, but they haven't sunk in quite as much. All right, absolute value of x equals 4. Obviously 4 works, but what else works? Negative 4. Anything that's when we take the absolute value, it has to be the positive or negative. So you got negative 4 and 4 will be your answer. What about the absolute value of x equals negative 7? No solution. The absolute value can never equal a negative. So anytime you got the absolute value equals a negative, you got to know no solution. And sometimes you'll see it written as the empty set. If you want to write out the words no solution, that's absolutely fine. So no solution for that. Okay, if you got something more than just an x, absolute value of 2x plus 5 equals 25. This is where we want to split it into 2 cases. So we want to split it into one case where it equals positive 25. And we want to split it into a second case where it equals negative 25. Okay. If it equals 25, then obviously the absolute value will work, or negative 25. Solve those independently. Okay, so those are just 2 separate problems. Subtract 5, 2x equals 20, divide by 2, x equals 10. Subtract 5, 2x equals negative 30, divide by 2, you get negative 15. So my 2 answers, negative 15 and 10. Plugging in negative 15, that gives me 2 times negative 15. Negative 30 plus 5 is negative 25. Absolute value of that is 25. Okay. Okay, for problems like number 4, you have to isolate the absolute value first before you split it into 2 cases. You cannot set this equal to 39 and negative 39. The second one will be incorrect. So isolate the absolute value first. Just the, not these. So absolute isolate. So go ahead and subtract 7. divide by 4. I get the absolute value of 3x plus 8. 3x minus 8. Why did I change that to a plus? Equals 8. Now, every time you have a problem like this, you're evaluating. If you get the absolute value equals a negative, you're done. You can just say no solution. But if we get it equal to a positive number, then we go ahead and split it into this time both cases. So 3x minus 8 equals positive 8, and then 3x minus 8 equals negative 8, and solve those independently. Add 8 to both sides. I get 3x equals 16. Divide by 3, and that's 5 1/3, or I'm just going to leave it as 16/3. Don't give me a rounded off decimal. Just keep it as a fraction. It's fine. Over here, add 8. Oops. I get 3x equals 0. Divide by 3, I get x equals 0. All right, so now we're done. And don't forget that 0 is an answer as well. So you get 0 and 16/3. All right, got to set it, you get the absolute value by itself. Once you get that, split it into your two cases. So, all right, number 5. Make sure you fill in the rest of that problem. Absolute value equals absolute value. All right. If they're both, this is going to, again, get split into two cases. Here's how you want to do this. You're going to take 2x plus 5 equal to 5x minus 4. That's the first case. Just drop the absolute values, set them equal to each other. Now, normally we set it equal to the negative. And we're going to do the same thing, but when you do this, you get 2x plus 5 equals the opposite of 5x minus 4. And you got to put that in parentheses. It really wouldn't matter if you put the negative on the first part or the second part. What I mean by that, and like I said, you don't need to write this down, but if you put negative in front of the 2x plus 5 and set that equal to 5x minus 4, it would all work out. Okay, either way. But I'm just going to do it on the right-hand side because that's just typically how we do it. So now solve both of these. Subtract 2x. I get 5 equals 3x minus 4. Add 4. 9 equals 3x. Divide by 3. You get x equals 3. Now to go ahead and distribute your negatives, see what you come up with. Carlos, what'd you get for the second part?
Negative 1/7.
All right, negative 1/7. Okay, I agree with that. On that one. So you get 2x plus 5, negative 5x plus 4 when we distribute. Add 5x, we get 7x. Subtract 5, we get negative 1. All right, negative 1/7. So x equals negative 1/7 and 3 for those cases. All right, so just be careful on that. All right, those are your equations. Absolute value. All right, I want you to think about that. On your guided notes there, you got put in absolute value of x is less than 2. You got a number line underneath there. What would be the graph? All the numbers that satisfy that. Just think about it. What are all the numbers that would make that true? And then how would you graph that? Okay. What are all the numbers that make that true? Colton, you got an idea?
Would it be all numbers less than -2?
So I'm gonna just graph this here. Whoops. No. Like this here.
Yeah.
All right. So I plug in -5. What's the absolute value of -5?
5?
It's 5 less than 2.
No.
No. Absolute value of -3. What's that?
3?
3. It's 3 less than 2.
No.
No. All right. So it can't be those.
Okay.
Correct? All right. So let's see what else is out there. Sorry, I had to use somebody's a guinea pig. All right. Kate, any ideas?
It's an open circle at 2 or -2 and 2, and then a line in between.
So like this, and a line in between?
Yep.
All right, let's take a look. Absolute value of -1 is 1 less than 2. Yep. 0. Yes. 1. Yes. Now what happens when we get bigger than 2? Well, it's just all positive numbers. So 3 is not less than 2. 4 is not less than 2. And we just showed here that these numbers do not work here. So that is the correct graph. That would be correct. All those numbers between -2 and 2. Now you got to remember this line includes more than just the whole numbers. It's not just -1 and 0. It's -1.5, -1 and 3/4, -1 and 7/8. All those are included. So all the answers, okay, will be from. So basically, -2 will be less than x, which is less than 2. All right, that's how you would represent that. And the interval notation would be from -2 to 2 on that. So basically, we can need all the numbers that are bigger than -2 and at the same time less than 2. All right, what if we switch this and make it greater than or equal to? All right, think about that. All right, so what graph would represent those numbers? Okay, see if you can come up with that graph. See if you can represent all those numbers. Casey, any ideas?
I just thought it would be like the infinity.
So
Everything is like infinity greater than, and then I can't speak today.
it's all right.
And then 2.
So from 2 to infinity, is that what I'm hearing?
There's a circle there, and then like the infinity. Yeah.
To the right? And is that it or anything else? Okay, I agree with that. That's part of it. She's missing a part. Nathan, you know what part she's missing? You haven't been here in a while, so we got to talk to you.
-2.
The -2 and then what?
Circle to the left.
All right, he says -2, circle to the left. Now, I agree, 2 to the right. Those are all the positive numbers. They got to be bigger than 2. Absolutely. What about the negatives, though? What about the absolute value of -3? Absolute value of -3 is what? 3. Is that bigger than 2? Yeah. So now we have to include all those numbers. Tell me how to write this as an inequality without the absolute value bars. How would you describe that graph? All right, how would you describe that graph? All right, Austin, any ideas? Like you were telling me what to write. Okay, you're telling me what to graph, and I can't, and I have no idea what's up there. So you have to pretend that. How would you describe that?
I would say that x is everything less than -2 and everything greater than 2.
So x is less than or equal to -2. All those, right?
Yeah.
And you said and
Yes.
x is greater than or equal to 2. All right, he's got one major issue we got to fix.
This should be or instead of and.
It's got to be or, because if it was the word and, what would that be? That would be the case. It would be no solution because it would have to work for both of them. So if I want to describe that, I would say x is less than or equal to -2 or x is greater than or equal to 2. So that's what that boils down to. Okay, x is less than or equal to -2 or x is greater than or equal to 2. All right, I think was that on the bottom? All right, we're flipping it over. And here's what the case is. Okay, we can take any absolute value inequality and we're going to rewrite it without the absolute value. We're going to take the absolute value out. Okay, and this is what's going to happen. If a is greater than 0, if a is less than 0, negative, we got issues and we'll deal with those in a minute. U is some expression. Okay, then if the absolute value of u is less than a, then basically we can rewrite it as negative a is less than u is less than a. Let me go backwards for 1 second. This is the first case. We just showed absolute value of x is less than 2, right? So we can trap it between -2 and 2. That's always going to be the case. And now if it's less than or equal to, then we just make these less than or equal to. If it's greater than, then we have to write it as an or problem. You got to say u is less than -a or u is greater than a. No way around that. You have to write it like that. Okay? So sometimes in the past you might have learned it like this. So this is less than, if you kind of write it like that, it's going to be an and problem. Remember, that's an and problem. And then this is greater, it's going to be an or problem. Okay, so if you got an less than, it's going to be an and, trapped between the two values. If it's going to be a greater than, it's going to be an or. Okay, for that. You kind of got to go back to just this. If you understand this, then it's going to work for the other ones. If it's going to be less than 2, you trap it between -2 and 2. If it's going to be bigger than 2, it's going to go to the right and it's going to go to the left. And you have to write it as an or problem. So now if you're given a problem, you're going to have to evaluate it and see, all right, how do I set this up? Absolute value of 2x minus 8 is greater than or equal to 16. So since it's a greater problem, greater than or equal to, okay, which of those two cases do we use? Do we use case 1 or do we use case 2? We use second case. Now, how do I write this then? Now, I like to write, okay, the way they have it done is I always start with the negative part first. Doesn't really matter which one you do first. I'm going to do this. I'm going to make this 2x minus 8 is less than or equal to -16, or 2x minus 8 is greater than or equal to 16. Okay? I want to do that. Solve those. Okay, now that's the hard part. You got to set that up right. Add 8. 2x is less than or equal to -8. Divide by, that's a -8. Divide by 2 and get x is less than or equal to -4. All right, same thing over here. Add 8. 2x is greater than or equal to 24. Divide by 2. X is greater than or equal to 12. All right, I need an interval notation. So every answer dealing with an inequality has to be an interval notation. So think about it. This is a case where I'll tell you if you're not quite 100% sure, then graph it out. All right, Josh, you think you know what it is in interval notation?
I do know.
All right, so I got it graphed out. X is less than or equal to -4. X is greater than or equal to 12. Is there any overlap? No, there's no overlap. We got to include all the answers because it's an OR problem. So we got two distinct sets. So I have to write this as -infinity to -4 union 12 to infinity, which means I'm grouping those two together. Union. Okay. No other way to do it. Okay. No other way to do it. All right. So that's greater than or equal to. You make it an or problem. Absolute value 5x plus 3, less than or equal to 12. Okay, less than. It's going to be an and problem. Really, two ways you can set it up. I like this easiest. If you look at what we did on this little statement here, you just make it negative of the A, less than. It's always going to be pointing in that direction. Whatever your expression is inside the absolute value, and then the constant that's on the outside. So I'm going to make this negative 12 is less than or equal to. You just have to use the same sign. 5x plus 3 is less than or equal to 12. Now this is an and problem. You can write this as 5x plus 3 is greater than or equal to negative 12 and 5x plus 3 is less than or equal to 12. I think this way is easier. I'm going to stick with this way. But some people still want to do it that way, and that's fine. But if it's less than or equal to, it's going to be an and problem, which we can write as one inequality all the way across the board here. Subtract 3, negative 15, less than or equal to 5x, less than or equal to 9, divide by 5, and then I get negative 3 is less than or equal to x is less than or equal to 9/5. All right, I need interval notation. Well, when it's like this, it's just trapped in between negative 3 and 9/5. Okay, so it would just be the interval from negative 3 to 9/5. It has to be brackets because it includes them both. Okay, for that. All right, so there's all your absolute value, or less than or equal to. All right, if you have something like this, before you split it, you got to get the absolute value by itself. So I'm going to subtract 3. And I get absolute value of x over 2 plus 12 greater than or equal to 8. Greater. All right. I want you to take a second, think about it. I want you to tell me how we're going to write this. Okay. Alex, how am I going to do this from here?
So would it be the absolute value is x over 2, well not absolute value, but x over 2 plus 12 is greater than or equal to negative 8?
Less than or equal to negative 8. You got to flip the sign.
All right.
Less than or equal to negative 8, and then what?
And then x over 2 plus 12 is that greater than or equal to 8?
Yes.
All right.
And make sure you use the word or. Okay, everybody make sure you put the word or in there. It's greater, got to be or. And it's all you're flipping that sign. You're flipping that sign because we got to go less than negative 8. Okay. It's a little bit easier to see when we do the first one. We just have like x is greater than or 2 or x is less than 2. All right, subtract 12. I get x over 2 is less than or equal to negative 20. Multiply both sides by 2. X is less than or equal to negative 40. Subtract 12 over here. X over 2 is greater than or equal to negative 4. Multiply by 2. X is greater than or equal to negative 8. All right, you got to put it all together. Give me that final answer. Okay, for that. Luke, do you know what it would be?
Would it be negative infinity and negative 40, and then union negative 8 to infinity?
Correct. Okay, negative infinity to negative 40, union negative 8 to infinity. It's an or problem. Okay, if it was an and problem, you'd have to say no solution because they don't overlap, but it is an or problem, so all those answers will work. So all those answers, you plug any one of them in. Negative 8 to infinity, I can plug in, say 10. 10 divided by 2 is 5. 5 plus 12 is 17. Well, the absolute value of that is 17. Plus 3 is 20, bigger than or equal to 11. Okay, so those all work. All right, a couple special cases that really don't require any work. Absolute value of 2x minus 5 is greater than or equal to negative 3. Don't start splitting anything up. I want you to look at it and tell me the answer. Okay, anytime you see a negative with an absolute value, you're just going to stop and evaluate it. Okay? So absolute value of 2x minus 5 is greater than or equal to negative 3. All right, who thinks they know it? Somebody. Everything works. Everything works. Why? Absolute value is always what? Positive, right? Will a positive number be bigger than a negative number? Yeah. Yeah. No matter what I plug in here, when I take the absolute value, I make it a positive value. It's got to be bigger than that negative value. All right. Likewise, what's number 2 going to be? What's that second answer? Absolute value of 5x minus 1 is less than or equal to negative 8.
No solution.
No solution. Will it ever be less than a negative? No. So anytime once you get the absolute value, if it's an equals, whether it's an equals or less than or greater than, you got to stop and think about it. Okay, stop and think about it. Okay, for that. All right, page 164. We'll review some tomorrow. I already gave you that review assignment so you could get ahead if you needed to. And then we got our test on Thursday.